This lesson will be on solving quadratic equations by completing the square. Now, the reason why we solve equations by completing the square is because sometimes the PSF method cannot be used. So when it can't be used, one of the next best options is to solve the quadratic equation by completing the square. So let's look at a couple of questions. Solve x squared minus 4x plus 2 equals 0. So to complete the square, what we need to do is x squared minus 4x plus minus 4 on 2 all squared. Then we balance it out. Minus plus 2 is equal to 0. This component here will give us x minus 2 all squared. And then over here we've got minus 4 over 2 is minus 2. Minus 2 squared is 4. So minus 4 plus 2 equals 0. X minus 2 squared minus 4 plus 2 is minus 2 equal 0. Now you'll need to recall the difference of two squares identity here. So we've got x minus 2 squared minus root 2 squared equals 0. So x minus 2 minus root 2, or x minus 2 plus root 2 equals 0. So x minus 2 minus root 2 equals 0, or x minus 2 plus root 2 equals 0. This will give us x equal to 2 plus root 2, or x equal to 2 minus root 2. And we can actually write these two answers in the format x equals 2 plus or minus root 2. Let's jump straight into another question. X squared minus 3x plus 1 equals 0. So let's go ahead and start completing the square. So we'll get x squared minus 3x plus minus 3 on 2 all squared. Balance it out. Minus 3 on 2 all squared plus 1 equals 0. Let's just focus on this component to begin with. That will give us x minus 3 on 2 all squared. And then we come over to this component here. Minus 3 on 2 all squared will give us minus 9 on 4 plus 1 equal to 0. We keep going with this. X minus 3 on 2 all squared minus 9 on 4 plus 1. So in other words, plus 4 on 4 will give us minus 5 on 4 equal to 0. So we can treat the 1 as 4 over 4. That leaves us with minus 5 on 4. Then we'll use a difference of two squares. So x minus 3 on 2 squared stays as is, minus root 5 over 4 all squared equals 0. From here we'll get x minus 3 on 2 minus root 5 on 4. I'm going to change to root 5 over 2. And then x minus 3 on 2 plus root 5 over 2 equals 0. Now just to come back and explain why I used root 5 over 2 and how I got that from root 5 over 4, you'll recall that root 5 over 4 we can write as root 5 over root 4, which equals root 5 over 2. Now let's keep going with this question. So using the null factor law, we know that x equals 3 over 2 plus root 5 over 2, or x equals 3 over 2 minus root 5 over 2. I'm going to write this with one denominator, x equals 3 plus root 5 over 2, or x equals 3 minus root 5 over 2. And a simple way of writing those together is actually just to write x equals 3 plus or minus root 5 over 2.